Okay, so today you're going to learn how to solve stoichiometry or stoichiometric problems just involving mole to mole conversions or mole to grams, grams to moles conversions. Now, when you're solving any stoichiometric problem, remember that you have to use mole ratios as conversion factors. So the first step is just to have your balance chemical equation. In case that you don't have the equation and you have a situation that the problem is describing, you have to write your skeleton equation. And once that you have your skeleton equation, you will proceed to balance your chemical equation. Because remember that you need the coefficient to write the mole ratios. Okay, and that's your first step. I'm not gonna waste time over here balancing this chemical reaction because you already know how to do that. If you don't know how to balance chemical equations, not reaction equations, just refer to another video that I have posted on the school website. But I'm explaining that over here. See, here in blue, you have the balance chemical equation. That's your first step, because without this, there's nothing that you can do. Why the balance chemical equation? Because remember that with the coefficient, you're going to start writing the mole ratios, because the mole ratios are the conversion factors that you're going to use to solve the problems. Another thing that you can infer from the balanced chemical equation is the amount of mole ratios that you have given the equation. In this case, you have 1, 2, 3, 4 substance. 4 minus 1 is 3. 4 times 3 is 12. So with this equation, you can write up to 12 mole ratios. Are you going to need all of them? No. What are we doing all of this, Ms. Ramos, when we only need the relationship between sulfur and the products? Just to practice. And look over here, because this is not a special case, because you're going to find this a lot. Okay? Since when I'm writing, see, this mole ratio between the first reactant and the first product, the numbers are the same, you have to simplify. 2 to 2 is the same as 1 to 1. So what to use 2 when you can use 1, and it's gonna be easy for your calculation. So every time that you have numbers over there that are multiples, it's better you simplify, because you're not gonna be working with the numbers. Okay, that's what I did over here. Remember that for every mole ratio you have the reciprocal, which is another conversion factor. In this case, you have 12, 4, see, 5, 6, 7, 8, 9, 10, 11, 12. And here, see, that I was also simplifying. Once that you have your mole ratios, you have to analyze. You have to ask yourself, you see that I'm always writing the equations, putting the information that I have. You have to analyze. What do I have? What do you have? This is information that was given in the problem. See, they want you to look for the number of moles that are going to be produced when only 1.50 mole of sulfur I use. Okay, by the way, this is methane reacting with sulfur just to produce carbon disulfide and dihydrogen monosulfide. Okay, why dihydrogen monosulfide? Because it's in the gaseous state. Okay, this is not an acid. So they want you to look for the amount of carbon disulfide that is going to be produced when only 1.5 mole of sulfur are used. And if you look over here, that's not difficult. You don't need to do all of this to find that. If per one of these I have 2 of this, if I have one and a half of this, what's gonna happen? I have to multiply by 2. See? But I was putting over here the conversion factor so you can understand the way that it works. So you're gonna start with whatever you have. You want to get rid of mole of sulfur. So when you're writing your conversion factor, you're putting that on the denominator. And now you have to look for a mole ratio that is relating the sulfur with the carbon disulfide. You're going to find that when you look at all the mole ratio. See, you find the proper one, cancel the units that you don't need, and then you multiply. In this case, you multiply. This is the answer, 3.00. Why 3.00? Because 1.53 significant figures, so the final answer with the correct number is significant figure. Now, look at the answer. See? 3 moles of carbon disulfide are produced with when you have 1.50 mole of sulfur and enough methane are in that reaction. And this is important because when we finish with this session, you will be calculating limited reactants. Because if you don't have enough methane to react with the sulfur, then you're not going to be able to have this amount of mole of carbon disulfide. It's very important to clarify that there, okay? That you need enough of the other reactant in order to have that amount. Same problem. It's asking you for the amount of the hydrogen monosulfide that is produced with the same amount of sulfur. So you're going to follow the same step of whatever you have in here. Okay, and this problem is easy because when you look at the balanced chemical equation, you see the relationship between sulfur and the two products. For 1 mole of this, you have 2 of this and 4 of this. You already know by looking at the equation that you have to multiply by 4. But I want you to practice using the mole ratio. So you write whatever you have, okay, and then you're going to multiply by a conversion factor. See, you have mole of sulfur, you want to get rid of that, you will put that in the denominator. What are you looking for? You're looking for mole of the hydrogen monosulfide. You will put that in the numerator. So you have to look for a mole ratio that have mole of sulfur in the denominator, mole of the hydrogen monosulfide in the numerator, and then you solve for that. Remember that the final answer has to be expressed using the correct amount of significant figures. And in this case, since you have sulfur and another reactant involved when you're writing the answer, you have to mention that you will have this amount of the hydrogen monosulfide if this amount of sulfur is given and you have enough of the of the other reactant that is involved in the chemical reaction. Because if you don't make that clarification, this number is not accurate. Okay, so enough, you need enough of the reactant that you are not analyzing, okay, reacting with the amount that is given in order to have this amount of products, this amount of mole of the product that you have in there. This is an example of another problem. Okay, see, in this one, they're not giving you the equation. Well, they're giving you like information. Is there the composition? You know that in the decomposition chemical reaction, you have only one reactant. And since you have an ionic compound, the ionic compound is decomposing into the metal and the non-metal. Okay? They are giving you all that information in there. So the ionic compound is decomposing into the metal and the non-metal. Since the non-metal is a diatomic molecule, this equation, the skeleton equation, is not balanced. So what is the balanced chemical equation? You have that over here. See that? The coefficients are balancing. You have 2 sodium here, 2 sodium, 2 chlorine, and 2 chlorine over there. Now, what is the amount that they're giving you? 2.50 mole of sodium chloride, and they want to know how many grams of the gas, or the chlorine gas, is gonna be formed after the decomposition. Okay, so once that you have your balanced chemical equation, you're gonna proceed to write all mole ratio. You have 1, 2, and 3 substance. 3 minus 1 is 2. So 3 multiplied by 2, 6. So these are your 6 mole ratios in here. Mole ratio. In this case, you don't have to simplify. Well, no, let me see. Yes. Okay, look over here. You have 2 moles of sodium chloride. They're gonna give you 2 moles of sodium. See that I did the simplification here. See, since 2 and 2, same number, you can simplify over there. For every mole ratio that you write, you have the reciprocal. You have the reciprocal. Once that you have the mole ratio, you can proceed to set up your problem. See, you're setting up your problem over here. See, this is why you have 2.50 mole of sodium chloride. You're going to multiply by a conversion factor. If you want to get rid of this, the sodium chloride, what do you think that you're going to put here in the denominator? You have to put sodium chloride. What are you looking for? Chlorine. That's the one that goes on top. So you have to look for the mole ratio that is relating sodium chloride and chlorine. Okay, it could be any of the two, because remember, it doesn't matter. The problem is when you're setting this up. That one, you will put it over here, you multiply by that. But if you decide for this one, you have to flip that up, okay, in order to cancel the unit of measurements. Once that you resolve that, okay, you will find the amount of moles of chlorine gas. So if you have 2.50 moles of sodium chloride, then, see, if since you don't have any more reactants, you don't need to worry about the reactants like in the other problem. So with 2.50 mole of sodium chloride are decomposing, then you're going to be able to obtain 1.25 mole of chlorine gas. Moles. Is that what you want? Is that what the problem is asking for? I don't think so. Okay. So let me go back over here. See? The problem is looking for chlorine gas in grams. Okay, so once that you have the amount of chlorine gas in moles, how you gonna convert moles to grams? What is the only conversion factor that is related moles and grams? The molar mass. The only problem over here is that, remember, the chlorine is a diatomic molecule, so you have to multiply the atomic mass expressed in grams by 2. You have over here, see, this is the amount of grams that you have in 1 mole of this diatomic molecule. With that in mind, what do you have? You have amount of mole of chlorine, okay, but you want that in grams. So you're going to set up your conversion factor properly. Since you want to get rid of the moles, moles in the denominator, grams in the numerator, and then you multiply. Once that you have the answer, just keep in mind that you have to write the answer with the correct amount of significant figure. Now, in this case, when I'm writing my answer, I'm talking about another reactant in there? No. Because remember, this is a decomposition chemical reaction. You have only one reactant, so you don't have to worry about writing here enough of another reactant that is involved. Okay, only when you have more than one reactant, you have to make sure that you have enough of the others in order for your answer to be accurate. Okay, questions about this? No? Okay. See that in this case, they were giving you moles, and then you have to find grams. But let's say that they are giving you, okay, this is just pretending that instead of giving you the amount of moles, they are giving you this in grams, okay? They are giving you the amount of sodium chloride in grams. Let's say that you have 250 grams of sodium chloride decomposing. Can you solve the problem leaving the grams in there? No. So in order to use the mole ratio, you will convert the gram of sodium chloride into moles. You will use the mole ratio to find the moles of chlorine gas, and then once that you have the mole of chlorine gas, then you will go back to the molar mass of chlorine and will find the amount of grams. Okay, so you have to play with the conversion factors. Conversion factors which are the mole ratio and the molar mass. In case that mass or grams, or see, the mass is given or mass is wanted as part of the answer of the problem.